hello. All right. Okay, let me just adjust this here. Uh-huh. There we go. How are you guys? Good? I hope you're not too hungry. Okay. Well, very excited to be here in India for the second time in a row. It's just amazing to be here. And I'm very excited to talk about generics today. I know that this is very new for PHP developers and can sound a little bit complicated, but we're going to dive into it today. Well, just to introduce a little bit myself, I'm Giovanny. I'm currently the engineer team lead at Worksome. And I have been working with PHP for the past, 20 years since PHP 4. And I have seen how PHP have evolved. And I think that before we actually dive into generics, I want you to take you to a quick journey through PHP type system evolution. Because I think it's very important for us to understand where we came from so we can appreciate where we're going and how generic is important. And PHP has come a long way when it comes to types, right? First ever we heard about types, any types of types in PHP was with PHP 5. Who here was since PHP 5? Yeah, there's quite a lot of people. So PHP 5 was the first time we got any sort of type hint, right? So before PHP 5, to make sure that a function receive, for example, a user object, you actually need to manually verify that through, for example, instance of or throwing some exceptions. And PHP 5 was the first time that we see that. So we could say for the first time that this function expects an user object, and PHP will enforce that. And it was a very big deal at the time, but it only works for classes. No integers, no scalar type, no integers, no booleans, nothing. And PHP 7.0 brought that to us. We finally got the scalar types. We could now say that this function takes an integer and returns an integer. And the declare types, the declare strict types at the top, that tells PHP on that file that you actually need to enforce the type strictly instead of trying to coerce values, right? And it was huge. Because suddenly, with this release, PHP started feeling like a real typed language. Then we came PHP 7.1, and we added more things like nullable types with that question mark, you can see. It was very important because we could express now that this function returned something, return user, but now could return null. Like before that, we need to actually use some doc blocks or anything, but now we could have this nullable type. PHP 7.4, that was also another big update because for the first time we could have not on the method only, but we could type your properties. So classes now could be more powerful. So because now we could actually declare that integer on a property on a class. And this actually helps the codes to be a little bit more self-documented, right? PHP 8.0 introduces some union types, and the most controversial one, the mixed, right? Love or hate it, but it's there. And we're going to see a little bit more about mixed later, but it was good. So it was a good release also for new additions, especially the union type. PHP, the modern ages of PHP from 8.1 to 8.5, it's where we got evolving every year with the type in PHP, right? PHP 8.1, we got enums, we had the read-only, and a lot of things that have been adding. So this is just for us to have an idea on how PHP actually evolved over the years on the type, right? But still, there's one thing missing. PHP still doesn't have native generics, right? So what we do, like how do we get type safety on collections or when you're reusable code or try to maintain information? There's no way natively now that we can do that. And the answer to it and how we can use it native, how can you use generics in PHP now is with PHPDocs annotations and some static analysis. And we're gonna see that in today. But what actually are generics? So generics are a way to write reusable code that works with different types while you're still maintaining type safety. So basically you write once, you use many times, and then you stay type safe. You can think about that as a ship container. The container itself is generic, right? It can hold anything. It can hold cars, furniture, electronics, anything. But once you decide that that ship container it's only take cars, you want to make sure that nobody's put any electronics on it or any furniture on it, right? So generics works on the same way. When you write a class or a function once, you can use it and you can specify it what type this function works with. So, and that's basically how and why you should care about generics. Because with generics, your IDE works better because you can have auto-completed for some classes. You can catch bugs before the runtime with static analysis. Your code becomes more self-documenting, so that's very, very important. And without generics, everything is mixed, right? Your IDE doesn't know anything. You just catch bugs during runtime in production, so it's very complicated, and you end up with very duplicated code. So let's have a look on a more or less real-world scenario so we can see how can we evolve a method to use generics. So this is a very common pattern. Let's say that we have a service class that talks to an external API. So you need to create users, and then you create a method called createUser. And you need to create products, so you write a method createProducts, right? You can see that both methods are basically the same. They are identical. The only things that is different is the endpoint that we're calling on this external API and the class that we initiate, right? The class that we are returning, the user or the product. Now imagine that we are creating 20 different of that, like orders, cards, or anything. You need to have 10, 20 different methods that does the same thing, right? If we want to keep type safe, that's how we do it, because you need to make sure that you're returning user, returning product, and everything. So we could try to simplify that, because it's doing the same thing, right? So we will create one method that takes the endpoint and also takes the class name and the array of data. But now we have a problem, because what type do you use for the return, right? Because we're returning everything. We could use union type, to start adding product, order, and everything. But the easiest way is just to add mixed. But there's a problem with mixed, right? Mixed can be anything. So when you use that class with the return mixed, basically your IDE doesn't know nothing anymore about what is returning your function. And that's the real problem with mix, right? You lose the whole context of the function. The PHP type system can't express this relationship. There's no way that you say natively on PHP that the return type depends on what you are passing in. And that's exactly the problem that generics are solving. So we're going to see how we can solve that with generics. like I said, PHP doesn't have native generics. There are some RFCs being discussed, but for now, natively, we don't have that built in the language. What we do now is the PHPDocs comments that you probably have seen around so many codes, especially in Laravel, and you probably have used them before. And those block comments are like that. They start with that syntax, and they have some tags that you can use, like to specify the methods and everything, like parameters or return. And the beautiful part is that the static analysis, like PHP stan, they can actually read those comments and understand the special tags, those special tags, and let us define generics on this. And the key tag that we're gonna be looking at is actually the template tag. And that's the key for the whole generics. So think like the template tag on a PHP block as a variable, but instead of storing the value, it actually stores the type that you want to use. So just like variable name, for example, it holds a string. In this case here, Lucas. When I write on the PHPDoc block template T, I can say that template T is holding a type. And I can use this type later on. Since it's a variable for types, you can use any name you want, but there are some naming conventions, like T we use for generic type, or T key, or T value, or T model for you use for that. So that's the basic syntax. So you declare template T, that's you're declaring your variable that holds the type. And then you can use that as a parameter. You say that the template T that you declare here becomes the parameter here, and also the return time. And here's the magic. The T is the same in both places. So if I pass a user, the T becomes a user, and the return type is also an user. If I pass a string, the return type becomes a string. And that type that you're using, it flows through the function, and that's the power of generic. I think it's going to be clear when you try to solve our API problem with that. So instead of the mixed return, we're going to remove that mixed return, and we're going to declare the template T at the top on the PHP block, and then we're going to use that as a parameter here, and we're going to see later on what is this class string. And then we're going to say that it's also return T. Okay? So essentially, on the users there now, when I'm passing a user class, the IDE knows that the return type is also an user. So I can use methods and everything from those classes. So the same type that goes in comes out. And that's the power of using generics on your code. And what was exactly that class string T that I just wrote before? So the problem of using a string there that as a parameter is that string could be and could hold anything, right? I can pass hello, 1, 2, 3, whatever. When I specify on a doc block comment that that parameter is a class string template, I'm just saying that it needs to accept a valid class name, right? And I can use that everywhere in our code. This pattern is actually very common, and if you dive in Laravel code, you can see that Laravel uses it a lot, and a lot of framework does it, right? So that's the basic of generics. It's you declare a variable to your stack analysis and say that you can use a variable and for types, and you can say and repeat that for your parameters and returns. This is very powerful. However, sometimes our template can be still very broad, right? And if we want to constrain even more. And, well, that's a scenario where that became a problem. For example, let's see that we have a log exception function. So basically, you're going to receive an exception, and we want to log it. We want to save it on a database or call an external service, whatever. And to do that, you actually need to access the get message method from inside the exception. So we need to make sure that you are receiving only exceptions on this. And the way to do that with generics is with the off keyword. So when you declare a template using the off keyword, you can actually restrain that to only accept classes that extends this exception. So using that, you can now safely get access to the get message because we know that your parameter, it's always an exception. And this will preserve the specific type. And if you pass, for example, a runtime exception or a you're going to receive a runtime exception back. So this is the best of both worlds, right? Having flexibility and also type safety. So here is another example of generics being used as a repository pattern. And here you can see different that I'm declaring the T here on the top of the class, right? And when I do that, the variable T, the template T, can be used on any method or properties on my inside my class. So when I declare the T model, the template T model off model, this repository works with only eloquent models. So the constructor takes a class string, defines method, return the T model or null, and when we instantiate with an user class, every method is now typed for user. This is much better than having user repository or product repository or order repository with all duplicated code. You have one single class that when you pass a type through it, it will return a type. So let's look at another more generic example, which I like to call the box example, because I think it's the clearest way to understand it. So here's a simple box class. Sorry. It has an array of items, and you can add things, and you can get the content out. But look what happens when we use it. Like, if you have a class like this, and we add a book to it, and then we try to add a toy. When I try to loop through it on my IDE, the IDE doesn't know what item is, right? And PHP stun also can help us catch errors. We're flying blind, basically. But if we define that as a generic class, I can declare the template C on the beginning and say that my item is actually receiving the T item or the same type that I declare on the top. My add methods also receive the same type, and my content return the same type. So, and when I initiate this class using the new box, sorry, I can actually define what type of box is this, right? So I'm defining here that this box only can receive books. So when I try to add a toy to it, PHP stand can give me, can catch this error before the runtime. In my IDE, we know that only this box only contains bugs, right? And that's the difference of using generics and not using generics. So without generics, you very likely you need to duplicate your code often and often to have type safe, if you want to have strictly type safe on your code. But if generic, you can be type safe without repeating your code. You can use multiple parameters on generics. You can create as many as you want. So here's another example of templates that you have. I have here three definitions: template key, template value, and template result, where the parameters receive key and t value. There's a callable, and this is basically the map array method. Generics in Laravel. So let's bring this home a little bit, and let's see how Laravel uses generics, and how Laravel. And I think generics is the reason that how Laravel gives you this amazing developer experience. Laravel uses generics everywhere. So collection are generics. When you have collections int user, it means that integer keys and user values. Relationships are generics. When use has many post user, for example, you tell the analyzer that this relationship returns post. Query builders, pagination, everything on Laravel uses generics. And this is why when you type user post first, your ID knows that it's a post, and you can access the post methods. It feels like magic in Laravel, but it's basically generics behind it. And here's how you can set up generics on your Eloquent relationships, for example. When you define this on your model, you define that the PHPDoc blocks that your relationship actually return has many bugs. When you're accessing your Laravel methods, you can you can show your ID that you are working with that type. And of course, to benefit from all of it, like I said, this is not native from PHP. You need to use a tool for that. And the two most recommended is the PHP stand, and also together with Laracon. Laracon is a Laravel extension to it. So it actually teaches your PHP stand about facades, relationships, collections, and all the Laravel magic. So it's basically simple. You install it with the composer, you create your config file, and you run your analysis. The pro tip here is to run your analysis on your CI checks, for example, on your GitHub. Every time that you are merging a PR, you can run that on the CI, and you catch all those errors before the runtime. Laracon have a lot of levels, from 0 to max, and you can play around with them to see how it works for your project. This is an example on how PHP scan can catch errors. Basically, if you run the PHP scan, you can see how it can show errors for you before the runtime. So when you use the Laracon or a PHP scan, that's what you get. You get model understanding, basically. You have collection intelligence, container arms, developer experience, everything. It's so good when you start using it, because you can catch those and you can work with your code more simple and more magical than before. So, just as a quick reference, you can take a picture if you want of this with this slide. Template T is where you declare the type. If you use the auth keyword, you can constrain that template to a specific type of classes. And then you can use it as a parameter. You can return that also. And the class string you return it, you constrain it as a class type. So the key takeaways for this talk, I think, is start using generics, start using the template, bounce when you need it, using the auth keyword, use class string for factors, for example, and stop using mixed all the time. This is not typing, basically. And try not to overcomplicate it too many templates. Well, you can get more from this on the PHP stand documentation, on the Laracon documentation. I think you just practice on your project. Install Laracon on your project. Install PHP stand on your project. You start with the level, low level, level 5. Run the command, see what you get, start playing around, and then you can get to know generics. There are some advanced topics that you can search off how to work with template covariant. If you explore Laravel base code, you're going to see that it uses all the time. So you can see how those things work. Well, and the best way to do it is just practicing, right? And that's it. I think it's a little bit of introduction of how generic works and how can you work with generics on your code. Thank you.
Thanks, Lucas. So, Lucas, I believe this is your second Laracon India as a speaker.
Second Laracon India in a row, yes. I came here last year.
And how is India treating you?
India, it's just amazing. Yeah. This time I had myself a little bit of more time before the conference. I brought my fiance with me.
Where is she?
She's there.
I believe Rafaela, right?
Yeah, Rafaela.
So, did you see anything else in India apart from Ahmedabad this time?
We did. We actually visited Jaipur. Is someone from Jaipur there?
Is anyone here from Jaipur?
Nice, yeah. We had a great time there. She's an architect, so she loves the buildings and all the palaces and stuff. So we had a great time.
Cool, cool. Now, let's take one quick question from the audience. This is from Chirag. At what point do generics start adding cognitive overhead instead of improving the code quality? What's your opinion on that?
Well, I think when you start overcomplicated things with generics, like I say, you can declare more and more templates. There's no limit for it. So when you try to use generics to overcomplicated things, I think that's where things got tricky.
Thank you. Now let's do a quick rapid fire questionnaire with you. So the first one, clear code or clever code?
Clear code.
Extra cheese or extra toppings on pizza?
Extra cheese.
Extra cheese. Examples first or theory first?
Example first.
Okay. Safety or speed?
Safety.
Readable code or maintainable code?
Readable code.
Confidence or convenience?
Confident, always.
Consistency or flexibility?
Consistency. Every time.
Consistency is the key every time.
Yes.
Early errors or late surprises?
Yes. Early.
What do you prefer?
Yes, early fun.
Okay. Refactor often or touchless?
I'm a very big fan of refactoring. I try to do that.
So do you try to refactor since the start or maybe after going midway in a project?
After a certain time, but I'm very fond of refactoring legacy code and bring it to more modern code and especially bring those new tools to the place, yeah.
The last one, Portugal food or Portugal beaches?
Ooh.
I'll add one more to that.
Portugal food.
Or Indian food.
Oh. Well, if it's Indian food, less spicy, maybe Indian food.
Of course.
But you guys don't know how to do less spicy, right?
Well, that's it then. Thanks, Lucas.
Thank you.
Thank you.
Thank you, guys.
Big round to Lucas, please, everyone.